All right, cool. So let me get to the actual demo, right? So I apologize it's taking this long to get there, but we're actually going to go through and kind of show actually how all this stuff actually works.
So while the demo's loading, I have a question for either our table or Geoff here. So for me, because I never existed in a world without microsegmentation, is there any use case against having a microsegmented environment?
It's harder to deploy microsegmentation. At the end of the day, if you just bought a dumb layer 2 switch and plugged other switches into it, it would work mostly, but it's very easy to take down such a network. That's my view.
It'd work always, but it's easy to take
Yeah. Yeah, it's just kind of.
I think it's easy to adopt microsegmentation. There's one hard discussion that's been made because you make it easy with the tools in order to, you get VRNI, you run it in there. You don't even have NSX. You identify what roles and rules and flows and how everything is and what you need to build upon that. The problem I tend to fall into, and whether it's leveraging NSX or third parties who stand up to try to implement something on their own, ACI, et cetera, it's dollars. It's not a technical thing. We took the technical problem out with the Nisir acquisition in the first place.
Yeah.
We set the framework for it. It's really been a dollars discussion since then.
Yeah, no, you're absolutely right. I was talking more generally on just from a switch perspective, like a physical switch.
What are switches? It's all VXLAN underneath the covers, right?
Yeah, I would say that the hardest thing I've seen for customers is going through the app rationalization part.
Yes.
Right? Is understanding how many applications you actually have and actually how many you need.
They don't need to understand that. They don't.
Well,
Well, and then you're going to.
I think it can reduce the time to value in terms of being able to start a microsegmentation project. When you go through the process should be, I need to document every application that I have in my environment. And then I need to understand, do I actually still need that application? Because I think that you could probably reduce 25-30% of the applications in most environments, right? Like some of these we don't need. Some of these are only around because they only need to be, they're only around in case we need to go back to it at some point. There's not a lot of value in wasting your time with applications that you don't need to go through that process. So app rationalization and understanding the applications, I think, is probably the part that takes most customers the longest time. After that, the tools are in place to help you get to that next part. It's a matter of, now I need to, how do you do DR, right? I got to figure out all my applications. I got to figure out which tier they all sit in and which ones need to be recovered first. Same kind of situation.
So is it fair to say maybe like big layer 2 broadcast domains exist as like technical debt? Mm-hmm. They just haven't been paid off yet.
Honestly, the biggest barrier to microsegmentation adoption is it's a layer 8 issue.
Yeah.
Politics, people. Oh, well, you can't do that. Like, no, you can. We don't know what it looks like. Here, this tool just showed us exactly what it looks like. Yeah. Well, let's have a meeting about this. Sure. Because the cycle is very long, not because it's technically hard. It was technically hard 5 years ago. It's much easier. It's just people, they want to drag their feet in something.
Well, if it works on segmented now, you don't get in trouble for stuff that works, right? Yeah. Like that's what it boils down to. This is hard. Security always adds a layer of complexity to any
single
project.
thing goes wrong, it's like your new project screwed everything up.
Yeah.
Exactly.
What's up with that?
And how often has it been just open the firewall and everything works?
Hard to pay down.
First step is understanding your environment, but I said this on Twitter, I close my back gate, but I wouldn't not lock my back door. So you have a perimeter firewall, but what happens when that fails? Because in our world today, inevitably it will at some point. So you need a second level layer of defense.
This gets back to what Chris was saying. You need a second level of defense. But now I'm weighing how much time, how much political capital, and how much financial capital. And where's the best investment?
True, but what's the time whenever you have a compromise?
Well, assume your firewall never fails. Assume your perimeter firewall never fails. The insider threat, they're doing what you allow them to do. And today, we allow everyone to do everything. This helps to minimize that significantly. So at least if you jump to a jump box, it's like, why are you doing that? You can't do that. You have no reason to talk to the domain controller on anything other than 389. But it should be SSL, but you know what I mean.
Yeah, 636.
Yeah.
They could be legitimate reasons why an external vendor comes into your environment to check their equipment, to check their systems or whatever. And providing security around that specific environment that only allows them to touch those environments disallows them from moving should somebody compromise a legitimate way through your firewall, which is the big thing. Like we need to allow this. We need to allow this vendor to come in because they need to run some queries on certain things or whatever. Those are legitimate reasons why. But then someone figures out the legitimate way to get into the environment, and then they try to compromise that. And then they try to move laterally from there.
Well, I've got, I can't tell you the number of HVAC systems I have that have ACLs on the switches. And maintaining ACLs? No. And it's horrible.
We need to have the HVAC discussion later, and I think Jerry needs to be a part of it. But
my very first CEO sit me down and said, the security team always wants to spend $200 to protect $100 worth of information, and the CFO always wants to spend $5 to protect $100 worth of information. And you got to figure out what the middle is, because sometimes it's worth micro-segmenting everything, but sometimes the data value just isn't there. And that's where security really has to understand both sides of the house.
And NSX does allow you to, you don't have to have firewalls in between every single virtual server.
Yeah, I mean, the firewall will always be there, but whether or not you're still going to use it, because it's still going to go through a default allow at the bottom, right? So the traffic is still going to traverse through our firewall.
Why not use it if you're applying it through a policy to all your VNICs? So why not just apply the policy once and?
Well, if you don't trust it, you can default allow, but no matter what, all traffic will pass through it.
I like
regardless.
the granularity that you get doing this, because I understand that you have maybe this HVAC application. If you're using Palo Alto, you could put a vSys, have that in its own vSys, and they don't get access to anything else. But then when you add that secondary application that they don't need to get access to on the same subnet as the other server, then this makes a lot of sense.
Yeah, and I think for something like an HVAC system or a big capital expense, it's not changing much. This makes sense. My question to you would be, what about the DevOps model where they're like, our applications will change every 5 minutes?
Yeah.
Sure. So for things like that, things for like container-based workloads and so forth, as they write their workloads using the network policy and creating a network policy. So if they change the application, then they should rewrite a network policy that could then be pushed to NSX, and then the firewalling rules can still come into place, right? So it's still, to me, it's still making the application owner aware of their security and making them still responsible, right? Because security is everybody's responsibility, right? That's the cliched thing, but when you do that, right, and you say that these workloads need to be secured, when you write your new application, you spin it up in Kubernetes, then write a network policy for how the containers talk to each other, and it immediately gets placed into the environment. If you need to change some things like that around, I mean, there's still going to be the applications that are going to basically talk maybe to that application in Kubernetes, right? So you're still going to have to maybe make those changes. But the nice thing is that from NSX's perspective, all you got to do is go to the firewall and make one simple change, and you can kind of go from there.
Or programmatic.
Or use tagging, or use things like tagging. Use tagging where immediately when those workloads spin up, they immediately go through there. Cool?
I mean, the bit that really stands out to me is I've been in so many situations where it's like they just need to open one thing on the firewall and they don't know how to do it. And then they do it. Yeah, well, there's that too. But it takes them like a month to figure out this one thing, and you can't just go and do it because you're not allowed, apparently. Yeah. But then I guess in this case, when they make the mistake and maybe open too many things, that actually is quite cool. It's like a secondary kind of...
A buffer to kind of help with that.
Yeah, and also, it might... Theoretically, it would be easier for them to understand, because there's always this like uncomfortableness with firewalls, and it's like, if I touch it, it's going to destroy everything.
But I think you could apply some sort of workflow where if the application owner knows what ports that they need to open, they could submit something, right? I'm assuming there's some sort of API that...
Yeah, so NSX has an API that you can... So that you can use. I would say that mostly the NSX,
if you create some front-end web GUI where they could put in, here's what I need, here's the purpose, and then that gets to an approver, and then you could programmatically put that into the firewall.
In my hope would be that they would be able to write that? Because I've seen it in like a situation where it's the firewall technically, the NLPO, fancy firewall, they do that, but they don't really know how the firewall works. And the people that are supposed to be maintaining the firewall don't really know how it works because nobody ever touches it, because if you touch it, you get in trouble because it breaks something. And so I'm hoping in this scenario it would be like a bit easier, like more friendly.
You can already have the security policy already in place, and you basically, as the application owner brings up their virtual machine, you say tag it with these tags, and they don't have to worry about the security policy at that point, right? Like you could predefine all those things beforehand.
Okay.
So that
Is there tag enforcement?
What's that?
Is there tag enforcement?
Sure, absolutely.
Like if I have a Linux box, but I know the Windows box
want that
is more open, I'm just going to tag everything with the. I'm going to tag all my boxes with the test tag because I know that they have that wide open.
Absolutely, right? So
permanent
tagging
thing.
it puts it into a security group, and what security group it puts it into is determined upon how granular or how restrictive you want that security policy to be. So if you tag it with test or you tag it with prod, it's going to be placed into the security groups where a tag is the criteria for adding a machine to that. You see what I'm saying? So you create the security policy, you create the criteria for things. So things like a DevOps model, right? So if I build these containers and I say that they have a name of a specific type, I can actually add those systems to immediately to a security group.
And that one seems really simple to me, right? Right now I need to spin up a 100 NLP instances with my own software that just needs to talk HTTPS. But what I'm more concerned about is in the case where it goes, yeah, now, NLP on our own stuff isn't working, we're going to use IBM Watson. And then they go, well, all right, so now we need to open these ports, but I don't know what ports to open. I need to submit a use case. Security is slowing me down, blah, 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 blah. So we just put everything in test.
Yeah, so I mean, you could do it that way, and then when you're ready, once your test could be a little more open in terms of.
I don't want them to, but that's my point. What's the quickest way to get this up and running?
Yeah, DevOps is like water. It's always going to find the easiest way.
Yeah.
And I would like to say, temporary solutions always are the most permanent, so they probably be in test for a long time. But my other question about that, kind of along the same lines, is there a way you can like make it temporary, like that you're allowed, like can it expire these tags? To like force them.
So the way that the way that the security tagging and the way that these objects exist is that once the object exists and it's tagged or placed into a security group, once the object does no longer exist, it's no longer part of that group. So the firewall rule doesn't. The firewall rules still persist, but they may not have anything actually in those groups. You see what I'm saying? So as you continue to spin these things up or spin these things down, spin them up, spin them down, the security is elastic. Think about something from a VDI perspective, right? 100 desktops in one security group, but all of a sudden now I need 2,000. And I need them to be the same security regardless of what the pool size is. The security footprint expands and contracts based on the number of machines that actually exist in the security group.
Rapid7 Nextpost does the same thing, is where the policies are based on how you tag the machines and they're dynamically added to the scan groups and everything. I get that, but I'm wondering like, how in a kind of management perspective, how can we verify that our people are not adding people into the test group, for example, for like ever?
Role-based access control.
So
we have a granular role-based access control. So networking folks can access the networking functions, security folks can access the security functions. Then we have things like that. So we have the ability to kind of restrict what folks can do.
Is there
from that perspective?
Is there an ability to say, I want to add my system to whatever group, I add it, you approve it or something, and then I realize that, actually I need this kind of access, so I can like submit, I want to change it to this, and you can approve that? Or is it more? That
process is still a little more manual, right? It's still a little bit more manual of how you add the systems to each other or add to the security groups. But there still could be a process that you could do. It would be like maybe some kind of like CMDB process or a ServiceNow, right? Where I say I need to change my access in NSX to this. It's a workflow, a ticket, and then go from there.
No, that's fine.
I think one of the things there is although developers can have their own tags, administrator can also have their own tags. And the group can be a combination of a developer tag and an administrator tag.
That's cool.
But how do you
Yeah,
handle
so it's-
conflicts between tags? So you got one rule applied to this tag, but then the sysadmin has the opposite rule.
It's a precedence, right? So think about it
So who has
when
the precedent?
Jeff took through the workflow, right? Think about it, you're building a fence and you're letting the developer play in that fence. Yeah, the first thing the developer will say is allow all, right? That's the easiest way. I mean, going back
So we're
to
going to say the developers are low on the totem.
Exactly.
Well, it depends on how you write the policy, right? Instead of-
Yeah.
So you can put priority order on the tags. You can.
Not priority order on the tags. You're just making a combination. So the grouping criteria now has a combination of your tag and the user tag. So you can say that anything that's spinning up on this cluster is always going to be tagged by an automated process saying staging, right? So the developer never sees that tag at all. The developer knows its tags and it just keeps on placing it, but the rules never get enforced.
When you,
I got
sorry.
So it's almost like a hierarchy.
Yeah.
So.
I mean, it's like
You
really
guys-
tag management at that point.
Has this been built into any deployment mechanisms like Jenkins or Circle, so that it auto tags, like especially in the containers? I'm waiting for the demo, but like
Yeah. Yeah. So go ahead.
So we have SDKs, but like because the tagging becomes like more of a business logic, like when do you want to do, what's your naming? So people actually we provide the SDKs. We have a Python SDK, a PowerShell, a Terraform provider. So people just use it to create their own logic around it.
Okay.
And you can mix tags in with the other factors, right? So you can look at like what the host operating system is.
Oh yeah,
Yeah,
That
absolutely.
conflicts with the
Absolutely.
tag.
Yes.
Compliance,
Yes,
one.
you can actually you can't actually tag the Windows machines with the Linux tag because
Yeah.
it's
You
Windows
could put
machine.
you could put up to 5 different criteria,
Yeah.
right? So it can meet
Yeah.
these criteria.
And you can also connect a tag with saying this tag plus this L2 switch. So you can go deeper than that.
The nice thing about tags is you could basically put them on any kind of the constructs. So, and then you could use those constructs to create your NS scripts, and I'll kind of show a little bit about that. Go ahead.
I got a question from
Yeah.
somebody on Twitter. Is the firewall product, is it able to act as a load balancer between two VMs on different hosts?
So I'm gonna. So the best answer to that is I'll show you.
Okay. Yeah, let's do it.
I'll show you. Yeah. So I'm gonna go a little bit quicker because we're running. I want to make sure Chris gets time to talk to the app defense. But basically, whoa, there goes the mic. Anyway, this is back basically just showing again what we're talking about: container-based workloads, private cloud, public cloud workloads, and bare metal style workloads from NSX data center and NSX cloud perspective. I want to give a little bit of overview of what we do from an NSX cloud perspective and how all this kind of comes together. So how we're able to bring these constructs from a public cloud into the actual NSX data center. Go ahead.
Is this a V or a T example?
This is a T example.
Okay, thank you.
Okay. So on-premises customer data center has the vCenter, the NSX, and has what's called a cloud services manager. These are eventually combining. Right now, they're two separate appliances. But the cloud services manager, what it does is it connects over either direct connect, express route, or site-to-site VPNs to your cloud provider. So a VNet or your VPCs, it connects to your AWS or your Azure regions. Inside those regions, it deploys what's called a public cloud gateway. That public cloud gateway is what's used to actually consume the networks that actually exist within the actual VNet or the VPC. So from the public cloud gateway's perspective, these two systems, the CSM and the public cloud gateway, communicate back and forth, and the PCG, or the public cloud gateway, sends the inventory information from the public cloud environment back to the on-premises NSXT manager. The nice thing about this is that these objects that exist in public cloud show up as local inventory objects. So I can now use those objects to create firewall policies. The VMs that exist, or the virtual machines, the instances that exist in the public cloud, have an NSX agent that actually runs inside that virtual machine. It can be automatically deployed from the PCG. So every time you instantiate a new workload in the public cloud, that NSX agent is installed into the system. That NSX agent is the NSX distributed firewall, the same distributed firewall that the virtual machines on premises get. So it acts in a very similar fashion. So when you manage a security policy from NSX Manager for both on-prem and off-prem, the firewall policies apply in the same manner. Okay? The nice thing is from public cloud perspective, the PCG acts as a watchdog. So the watchdog meaning that it's taking a look at the workloads and making sure they're staying managed. If someone disables the agent, there's an option to actually quarantine. So the PCG will call native APIs of the public cloud and actually place that workload into a quarantine group where they get all security and basically completely locked down. So if you disable the agent, you're going to be quarantined, okay? And it's actually native to the actual public cloud instance, okay? So what we're going to do, back to Jeff's question, to the online question, is this is what we're going to show. On-premises and off-premises, we're going to show an EMR application that I have. It's got 2 front-end web servers that exist on-premises, and we're cloud bursting to one of our public cloud providers to actually place the other front-end system. Back to Jeff's question, the online question about load balancing, I'm actually going to show you that I can actually load balance between on-prem and off-prem using NSXT. Okay? These systems have a firewall policy that disallows communication between the web instances because we don't want the web servers to talk to each other. The web servers communicate to the EMR database, and then those other systems also have a connection to an Active Directory domain controller for things like DNS and AD and NTP. Okay? Here's our ports and protocols. I'll show you a little bit about, go through the NSXT interface and kind of show you what's going on. Go ahead.
So just a quick question on this, and maybe not directly related to the demo, but more broadly. So I know you're calling it more NSX Cloud and NSX On-Prem, right, versus NSXT and NSXV. Is NSXT like caught up and fully featured now? Because I was just interesting to me that you're using NSXT On-Prem. Is that to get?
Yeah, so NSXT On-Prem is the only version of NSX that can integrate with NSX Cloud.
Right.
So NSX Cloud was a SaaS offering that we moved back to on-premises. So it's a cloud services manager. They'll eventually be merged together. So the cloud services manager will run inside the NSXT manager or the unified appliance, and you won't have to run 2 different appliances. But to do cloud bursting or to do the kind of cloud technologies that we want, you need to use NSXT. Okay, that's the version that I'm showing. That's the reason why I'm showing that. Right. Make sense?
And is it feature parity with NSXV now, or is that still?
The next release of NSXT, which will be sometime in the first quarter of next year, will be very, very close to on par in terms of the feature functionality. So things like things that don't exist now will most of those will already be into the NSXT platform.
Thanks.
So a lot of the things that you're accustomed to from V will be there. Okay. Yep. So let me flip over here real quick to go through this. I'm going to kind of speed through just a little bit. So I'm logging into the NSXT manager, and then I also have the cloud services manager. I'm doing some zooming on this because I know it can be kind of difficult to see from time to time. I have an EMR application. This is that EMR application I was talking about. This is running on premises and also in the public cloud. In this case, it's running in Azure. So I'm logging in just to show the application itself. I'm doing some searching. Folks that are Tombstone fans may know this entry. I had to put something in there. Johnny Ringo, he was not a daisy. But anyway, this is just to kind of show that the application is functional and we're able to get to the application. If you can see up here, I'm going to 192.168.1.12. That's actually my load balancer VIP. So I'm load balancing all my connections between the 2 on-prem and the 2 off-prem systems. So I'm going to go in here and show you just real quick in the Cloud Services Manager the connectivities, right? So I've gone into the Cloud Services Manager and I've connected to my Azure environment. When I take a look at my instances, I'm pulling in the information from my Azure instance that actually shows me the workloads that exist in the public cloud and the public cloud gateway. We have the NSX gateway that's right here. That's my public cloud gateway that's connected back to my Cloud Services Manager. And here's that EMR server that actually exists there. We can see that it's checkmarked, which means the agent is running. I can see my private IP address for running these actual infrastructure pieces. So this network is a network that was created in Azure that's specific that I'm allowing across the VPN tunnel so that these systems can talk to each other. Okay. Going back to NSXT from a dashboard perspective, we can see that I have an NSX manager, all 3 of my controllers, how many hosts and edge nodes and so forth. I get kind of a nice dashboard here, kind of showing all of the different types of workloads that are actually running into my environment. So let's take a look at virtual machines so I can kind of show how these virtual machines kind of show up in my inventory. So what I'm doing now is I'm doing a search here through my inventory, and you can see that I have my 3 web servers that I talked about before. If you take a look over here on the right-hand side, you see that this one here is the PCG. That means that that's coming from the public cloud gateway. That's an inventory object that's coming from a native public cloud environment. The other 2 systems are coming from 2 of my ESXi hypervisors on premises. Okay? So if I take a look at my my cloud-based VM, what I can see is this is a feature functionality that's very cool from an NSX cloud perspective. If you use tagging, we talked about tagging before, so you can use native Azure or AWS tags and actually apply them to those workloads, and we bring those tags into the NSX Manager, which means I can actually use a native Azure or AWS tag to create an NS group, to create a security group with. So as my developers or whatever build new systems in Azure or AWS or whatever, as long as they provide tagging information, I can actually use that information to provide for a security group. What we do now is we're going to take these systems and we're going to build a security group for them, right? So I created an NS security group, or it's called an NS group in NSXT. I've created some membership criteria where I basically said that I want to bring in all the systems that talk with IAD, EMR Web, and the members, as you can see from here, when I select virtual machines, show all 3 of the virtual machines from the web front end. So I've used a specific type of criteria to bring those systems into this NS security group. I have other security groups for here for the database and so forth. When I go to the distributed firewall, I want to go back and kind of explain. So Chris, you'd asked about PKS and you'd asked about container-based policies. This is how policies show up from a container perspective, and it might be a little difficult to see and read, but functionally, when you create a network security policy or a network policy in Kubernetes and apply it through whether it's PKS or upstream Kubernetes, it doesn't matter. That information is translated via the NCP and placed into the NSX firewall, and this is placed in these groups, and it's based on how you create the network policy from that perspective. So looking at this from a container-based perspective, like we said, we were able to secure containers and bare metal types of systems. This just goes to show that from one interface, we can show how to actually do security for containers as well. What I'm going to do now is
important.
Go ahead.
You're not picking each individual object and then adding them and maintaining and adding and
So we talked a little bit about how to actually operationalize microsegmentation, right? So I talked about shared services, right? So I have a shared service section within my firewall that has all of the Active Directory pieces, has the security and so forth. I'm even allowing some SSH and RDPs and pings and so forth, right? Because if you turn those things off, then if you can't ping, what's usually the first thing you try, right? You try to ping the box. So I've added in these services here. And these services are CAN services, but that doesn't necessarily mean that we have to use the CAN services. When I expand the EMR section, we can see that I've created some firewall rules here for these systems, and I've actually created a custom TCP object, right? Because this is actually answering on 8080. Okay.
Like a reverse proxy or something.
Sure. So the VIP is going to 8080 for the load balancer and allowing that port to go across that. Right now, I have one policy in place that says the EMR web cannot talk to the EMR webs. And then what I'm going to do now is just show just how quickly I'm going to drop traffic between the web and the back end and show that now when I go back over here to create a patient or move in the system, you can see that everything is starting to time out. So that's how fast that I'm able to apply a security policy and have it done. I don't have to wait for an Active Directory group policy update or anything along those lines. I'm immediately getting policy in place. And if I go back and do an allow and republish, we can see that I'm back to the login screen and the application is functional the way that we would expect it to work, okay?
Can you
Tell
us what the rules look like on the back end in Azure?
I'll show it to you. So going back down here to the EMR web, right? So we said that we didn't want to allow the web traffic. So what I'm doing now is I'm going out to Azure. So this is my Azure workload that apparently needs some more RAM. And just to verify, to double verify, you can see that this says Microsoft Corporate Virtual Machine. So I'm not fooling, right? So I'm Def Leppard. All right, cool. So what we're going to do now is I'm going to actually do a command from here, and you can drop into the NSX CLI from the actual command prompt, right? So I can do, once I drop into the CLI, I can do a get firewall rules. And it's going to show a lot more because I have some other things going. But let's take a look at this real quick. 1144, 1226, 1145, 1256. You asked a question about how the rules show in here. Input-output protocol from any address set. I can do a search and show you the address sets from these to those address sets. Those UUIDs respond to an IP address in an address set, okay? We're doing drop with log. 1256. Let's go back to the firewall real quick. What is rule 1256? This group to this group drop. Okay, so those rule IDs that you see in the firewall or in the firewall output correspond to the rule IDs in the distributed firewall. So it's very easy for you to go through and say, okay, maybe something's blocking a communication. I run this command and I look through there and I go, oh, there's a rule here that's got a block in it. Maybe I need to go check it. Well, how do I go check it? I go back to the distributed firewall. I look for that rule ID. I find the rule ID, and then I find out why that's causing that traffic.
So is this distributed firewall host-based then? What is it doing to the cloud provider's security group?
So so basically what this does is it's using OVS, right? So it's basically bridging through the interface that's in the public cloud, right? So instead of going straight through directly to the Azure switch, it's going through an OVS bridge over to our firewall into our contractor,
Yeah.
and then we go from there.
So the public group the security group for this box in Azure is just blank. It's nothing allowed.
You don't have to use any of the security groups in Azure. You can use native distributed firewalling, and you don't have to worry about anything from the public cloud provider.
So Jeff, are you able to show the handoff for like IPS to Palo Alto or Fortinet, or like hand the SSL off to Gigamon or something like that? Some way, like where it is in the interface on how that integration is done?
So I don't have that.
Yep.
So where you would do that is there is partner services here. And you would go through here and you would create a service instance from this perspective, and that's how you would add in
in each of the roles.
And then you would go into the distributed firewall, and there would be an option for redirect, and then you would redirect. Okay. So remember how in the firewall I have drop, allow, and reject? There would be a redirect option. Okay, and that would send it to the third-party provider. All right. So. One last thing here that we're going to kind of go through is I said that the web servers couldn't talk to each other, but let's just show that the policy works the same way regardless of whether I'm on-prem or off-prem. So I'm going to try to do a browse to the admin share of one of the other on-prem web servers real quick, and it's going to time out here. But what I'm going to do is I'm actually going to go over to the firewall. And instead, I'm going to go ahead and allow those two systems to actually talk to each other. So I'm going to allow and publish. I'm going to go back. It says it's canceled now, but when I hit OK, give it a second to apply. Go through here real quick. Let's just cancel this out. I think I'm putting in the wrong IP address. Just a second.
Dang it.
Yeah. We'll just do it the easier way. When I show the rule ID here, 1256 used to say drop, but now it says accept. Right? So the policy has already been applied, and it's immediately taken effect. It's just, for some reason, this box is just being funky. So, but the point is that the firewall rule has already changed based on my changes to the on-prem environment. So let me do one last thing, one last real quick thing. Geoff had asked about the load balancing piece. So what we've done is we've created a load balancer in NSXT. I've created a virtual server. So this is the VIP. This is that 1.12 VIP. And then I've created a server pool for these systems. And in the pool members, I have the two on-prem and I have the one in Azure. I'm going to disable the two on-prems. Maybe we need to do some work on those systems. Go over to the pool member statistics and refresh. You can see that there's some connectivity going on there. But what I'll do now is I'm actually going to close the application and relog into it. And you can see that the application still responds even though I've disabled the 2 on-prem boxes. So this is actually sending the traffic out to the public cloud provider and then back on premises to the database. So when we go into NSX and you actually do a refresh, you can see that the number of connections has changed, and the only up front end I have is this one here, and the number of connections has changed. So that's real quick, shows you how you can do the load balancing for on-prem and off-prem using NSX Load Balancer. Okay?
And that is that application specific? Is it only HTTP apps, or could you put
No,
data servers?
so our load balancer has SSL. I mean, it can do things. Yeah, it can do all of those different things. So we don't do that at the distributed firewall, but the load balancer, you can do things like SSL proxy, SSL pass through, and things of that nature. Okay.